Hello, welcome to our broadcast. Just give people a short time to join. Okay, I'm hoping you can hear me okay. If not, then please let me know. We have the live chat available there. Yeah, so please let me know. All right, I'll just, whoops. I think I've lost my, there we go. All right. Good, thank you, Frozen Artichoke. Great. Okay, so let's make a start. Welcome, everyone. Yeah, I hope you're all having a good day. So this is a short introduction to security considerations on MINA. And this is part of our community initiatives at XtraP. We are trying to help developers on a number of blockchains, MINA and Starknet and Base. So we have initiatives on all of those. We're trying to increase security and keep the bad guys out of our applications and provide resources and education for developers. So this is the start of our initiative, looking at the MINA blockchain in particular, and this is going to continue. So this is a workshop. This is going to be a short introduction, and then we're going to continue with an audit course, which I'll talk about at the end of the broadcast. It is the first time that we've used these slides, and also that we've done streaming quite like this, so please bear with me if we have any hiccups, but I think we're all okay. So yeah, let's make a start. So yeah, so this is the, if you want the slides, yeah, they're at mina.xtrap.io, and this is the security workshop. Okay, so when we're thinking about security, we can think about it in layers, because obviously there are aspects of security that existed before blockchain and before zk applications, before MINA, that still are relevant, and we need to obviously take those into account as well. It's really, as we move to new technology, we're really adding other aspects and other considerations to what we need to think about for security. And so the Web 2 security still applies, and you have to be careful about how you handle keys, etc. And Web3 security still applies. And what I'll be talking about today really is to concentrate on security around zk applications and what new things we have to think about for that. And then in particular, looking at MINA and looking at what we need to think about when we're writing our zkApps, how to make those as secure as possible. Okay. Whoops, go too far. Okay, so let me start off then by looking at zero knowledge in general, and zero knowledge applications in general, and just the different protocols as well. And there's been there is some research been done on this. There are resources available for you. Obviously, it's still very early days, and even more so with MINA. But there are things that we can say about zk protocols generally that are also applicable to MINA. And so I've got some things here. One of them is about the implementation of zk protocols and applications written for those, and some of the details of that, of the way that we actually implement these, is that we're using cryptography. We need that to create our provable code, but this is based on finite fields. And what does that mean? Well, that means that we're going to be using integers, that they have a maximum value, and that modular arithmetic is used. And we'll see a little bit later the impact of that, or what that could mean. And if we think generally about what an attacker can do, well, they can break privacy, for example, if privacy is important to our application, if we're using the zero knowledge aspect of a zk proof, so that could get broken. Also, maybe they could create a false proof, and the example I've got here of minting zcash. Yes, remember, still I'm talking about zk in general, but this is something that we'll obviously go into in a lot more detail, and we'll be thinking about what a proof means, and that's obviously an essential part of our zkApps. And another point, I think perhaps a more subtle point that is still worth thinking about, worth remembering, is that because our users and the community in general are thinking about these applications, and they see the fact that they're involving a zero knowledge proof, which seems a very rigorous and something that obviously can't be easily broken in a sense. I think the fact that we have our mindset around that, and we have some kind of faith in the proof then, and that could mean that we would take more risks with our applications than we would in, say, a Web 2 application, where we're obviously more we would perhaps have less faith in the code, and we'd be more aware that the code could be hacked. But with the zero knowledge proof, we would perhaps we would take more risks, because we think that because there's a proof involved, and because of all the rigorous mathematics and cryptography involved, that therefore the whole thing is much safer. And so what that means for us is that we really need to live up to that assumption and up to that faith, and make sure that the proof that we have really is doing exactly what we want of it, and that the assumptions that we've made about the security of our application are justified. Okay. So if we look then at some of the common vulnerabilities in zk applications, so the common things that you see, I'll just mention two things here, but they are both relevant to what we need to think about with MINA. And one of I think the most important ones is the idea of under-constrained code. And this is quite a wide sort of area, but it is very important, and I'm going to be looking at it in more detail around MINA. But the general, what we mean in general by this is that we have some zero knowledge proof that is supporting some claim that someone has made, and we need to be sure that that proof actually does test that claim. So the verifier, when they are checking the proof, they are that proof contains some kind of test which we are assuming would fail if the claim is incorrect. And so the verifier has that assumption in mind, has that mindset, and they are going to be accepting the proof as being, and verification of that proof as being a proof of a claim that someone is making. Now, obviously then we have to have the link between that claim and between the proof. That proof really has to absolutely test whatever claim that person is making. And if it doesn't test that completely, then that is where we get something called under-constrained code. We've written an application and we've put some constraints in that. We've put some tests in that to show that our application is behaving in the way that we expect. But maybe we've missed something out, and it would be possible for someone to produce some code and produce a proof that looks as if it is supporting that claim, but is actually only testing part of the claim that someone has made, and therefore isn't a complete test of what we think it is and what the verifier is expecting. Okay. The next point comes from the fact that we are using integers, and we're using finite fields, and this is that we can get underflow and overflow with the arithmetic that we do. And generally speaking, we have to be more careful about the arithmetic, that it's not going to behave in the same way as the sort of common everyday arithmetic that we do. And so we have to be more careful about it. And this example that I've got here is taken, I think this is from zkApps. So this is another zk protocol. But what they've got a piece of code here which is saying that A is made up of x plus y plus z. And so if you were looking at that, well, you think, well, okay, there's, if we say that A is going to be 11, then we think that, this is probably going to be x is going to be 5, y is going to be 6, and z is going to be 0. But we can get a similar thing by using overflow. If we take x as 5, y as 7, and z as p minus 1, where p is this large number there. So we have to be careful when we're doing arithmetic that we're not making an assumption about the arithmetic involved, and that we take into account the fact that there could have been overflow or underflow. And in order to do this properly, what we really need to do is to put in some kind of checks about the size of the values that are involved. We need to put in range checks to then constrain the values to be within a certain range to prevent overflow happening. Okay. So if we turn then to MINA and think about the security model of that, we have perhaps even a more complex or sort of setup than we have with other zk applications, in that, of course, MINA is talking, what we're doing off-chain computation, and then we're sending that an update on-chain along with proof that the computation has been done correctly. So you need to bear that in mind, and it can be difficult to get your mind around that if you're coming from a different background, even if you've sort of come from a Web3 background. If your mindset isn't around the fact that we're doing the computation is being done off chain, then it is easy to mistake exactly what is happening and to get the security subtly wrong. So I just put these details here just to remind you really about how zkApps work, just to really emphasize this fact that you need to bear this in mind when you're thinking about the security, and particularly if you're thinking, well, what could possibly go wrong? How would somebody attack my code, and how could what sort of vulnerabilities could there be in my code? Then you need to be aware of actually what is really happening behind the scenes. And so, of course, we're going to write our zkApp, and this will get compiled, and then we can create a proof of this, that the thing has run correctly. And this is going to produce some updates as well, the account updates. We have a list of these that are updating the state of the accounts involved in our application. And what we're really trying to say is that we're taking this proof, and we're saying that our code ran correctly, and here is proof that was done. And we're saying to the blockchain, well, we want this account to be updated. We want these account updates, this state update to be applied. And really, it's up to us to do the checks to make sure that is being done correctly, and that we have the security around that. And what the MINA blockchain is doing effectively is really relying on us to provide that, and assuming that is all going to be within our proof, that our proof has all of those details. It is completely trusting us with the proof that we're supplying. And so we get our proof, and the updates, these are signed and sent as a transaction, and then the network is then going to take that and verify that proof is correct, and then apply those particular updates. So it is very much down to us to be specifying and to have checked that everything is being done correctly within our zkApp. Okay, so when we're thinking about security, one way to approach it, and I think one way that is useful, is to think about what an attacker could do. And I'll come back to this and talk about the sort of attacker mindset a little bit later. But I think it's useful to think, well, what could possibly go wrong? And you could, before you get into sort of the nitty-gritty and the details of a particular application, you could think about it in very general terms. And one thing that an attacker could do is some kind of denial of service. Now, this is perhaps a little less common than the second point, but I'll just mention this first. So it is something that maybe we might not think of as much when we're thinking about security, but it's something we need to remember, that somebody could do something malicious to try to prevent our application working, either completely or in part. And it is perhaps less common. Perhaps the main things that attackers would want to do would be to steal some funds or to make some kind of update, some state update that will give them something, some asset or something like that. But it is still possible that they would do some kind of denial of service against our application. Now, one of the things that people think about when they are trying to guard against these types of attacks is they think, well, we assume really that the things like transaction fees are going to make it less likely that people would sort of continually attack our application. It certainly gives a cost to some of the attacks. But something to bear in mind about when you think that is that if you've written an application, maybe that application is maybe some DeFi application or something that is has high value in some way. It may well be that you have competitors, and those competitors may well be prepared to spend money to try to disrupt your application, to prevent it working. So don't rely on the fact that we have transaction fees to make you think that people are not going to spend some money to attack your application. Another thing to remember as well, although I don't really want to overemphasize this, but certainly when we're thinking about security, we will be talking about we should try to lock down things as much as possible. But you do also need to be aware that you can make your application too fragile to some extent, and you can. It is possible to get permissions set that will prevent your application working. So do be aware of that. That is sort of the other side of the coin when we're looking at security. But anyway, that denial of service aspect is perhaps less common, and usually what an attacker will want to do is to make some updates, and maybe they can steal some funds, maybe send a transaction that they to get some assets that they shouldn't be able to do. And generally this is the most common types of attacks you see. And this makes sense because when we have applications that are holding value, obviously that makes them a target to attackers. So it's going to be a motivation for people to attack your zkApp. And so a lot of the sort of work that we're going to do and a lot of our thinking around security is going to be to try to prevent this and to make sure that all of the updates that happen are happening, are valid, they're ones that we are effectively would approve of, and obviously we need to get this sorted out in advance. We need to set up the authorization and the permissions in advance to make sure that is the case. And this comes down to the general area of access control. And when we have an application that's available on some sort of blockchain, then if it's a public blockchain, this means that anybody can try to interact with that. And of course with MINA it is slightly different, but it's still the case that people will be interacting with our application, even if the computation is being done off chain. It still could be open to anyone to interact with our code and with our application. And so we do need to be aware of exactly how we want to control that access. Sometimes, of course, it could be that you don't want to control it, that you want anybody to be able to call a particular method, and that is a valid way. That's the way that your application works. But quite often it's going to be the case that you would want to restrict that in some way. And this is where we have permissions and authorization to control the way that can be done. It's also useful to think about this in terms of if you think about it from the attacker's perspective and what can they do, and really they are going to be typically trying to call your application. Well, the computation is being done off chain, of course, but they are effectively getting your application to do some computation, and within that they would you've exposed some or made available some functionalities, some methods that they're going to be calling, and within that what can they do? You've restricted, you've given them a certain choice, you've effectively exposed your application to some extent. But what could the attacker actually do? Well, what they can do is try to manipulate what they provide in terms of data to make, to craft something malicious in such a way that they can then get something from your application that they wouldn't have been able to get. Now, you've got to try and make that as hard as possible. You've got to try and prevent them from doing that. And so if you don't have any sort of authorization or any permissioning around your application, then it's easier for them to go in and make any changes that you want. So that's why we have to try and lock things down as much as possible. And then it's just going to be the case of, can they somehow manipulate their input to the application to do something malicious? And again, we can guard against that because we can sanitize inputs to the application and make sure that any type of input is valid and is checked for validity in some way. Okay. So let me move on then to some further details about this, and we'll start by looking at permissions, and this is what is done when we try to get some update to the state. Now, I've taken these details have just been taken directly from the documentation. I'm just going to go through them fairly quickly. They're really just here for your reference, and there's a link there to the documentation as well. You do need to be aware of the difference between permissions and authorization, and I'm going to come on to authorization in a moment. But permissions is all about who can do something with our application, who can execute a particular action. And so we've got the choice of setting this up to be these different values. I'll just skip through this. We don't really need to say much about this, but they do relate to different use cases. We do have, I'll go down to that if hopefully I've got this. We do have some default permissions, as you can see here. I'm sorry this hasn't come out formatted very well, but these are the default permissions for these, the default values for these different permissions. So for Reddit state, as a default, we require a proof, and similarly for send, etc. So that is what we would have by default, but you can change these if you want to. And certainly one thing that you can do and you need to be aware of is the difference between a signature and a proof. Because there is a subtle difference there, they're used in different ways. And so if you're setting something to be a signature, then that means it's the owner of the zkApps, so the person who has the key that was used when we deployed this, who is going to be allowed to do this. So this is typically, this may not be what we want, because often what we want is the ability for other people to be interacting. So of course there is some things we will want just the owner of the zkApp to be able to do, but mostly with the business logic, the less kind of administrative things, then we would want other people to be able to interact, and that's where we want to be able to use a proof. And then if that's the case, then we're relying upon that proof to have checked or to be showing that we have done some checks, or to involve some checks that the permissions or the what is being done is what we intended. Okay. So that's the difference. But you've got the details there if you want to go through them. But you can just start off with the default ones. Okay. So if I move then, if I move then onto authorization, this is then the case of, we're not saying who is allowed to do something. We're saying, well, what is that person then allowed to do? What changes can they actually make? And so you've got the different types of authorizations here. And again, we can have proofs involved, or we can have signatures. And then we can set the authorization to be various things. Of course, the most permissive is going to be to set no sort of authorization at all, which would mean that anyone could. Oh, sorry, I've got the. I think maybe I've got these the wrong way around here. Okay. Yeah, but have a look at the docs anyway, and make sure you've got that correct. 'Cause I think I've got the details there about the permissions again. So I'll just move on then to this example here. If you use if we have here that we require a signature, as I said, this is the point that this is going to be, we need the account owner to be signing this. So typically what we have is the wallet is going to be signing the transaction as we're sending a transaction in to be processed. But if you want to do things differently, then you do need to make sure that that is going to be signed by someone. So here we've got the fact that we've got a private key to do that. Okay. If you did this, but in the init method where we're setting the permissions, if you set this to be none, then this would mean that there's no checking at all being done. So some malicious actor could go in and really do whatever they like. So they could, for example, drain funds from a particular contract. Okay, and then this also ties into the fact of what can we do with our zkApp as well, whether we can make this upgradable. And this is for the set verification key. And the options that we have generally when we are doing permissions is that we can set a permission of impossible, which will mean that then this is not allowable. So if you set this for your app, then this would mean that is not going to be upgradable. So it's a way to ensure that. Okay. Let me move on. So I'll move on then to some of the best practices. What can we do to make sure that we're developing in the best way possible? And so I've listed out some things here. So the first one I think is true generally, but it certainly has been highlighted, I think, with MINA and with the O1JS library, that you really do need to work with a compiler. I tend to think that generally with languages, the compiler is there to prevent me from doing stupid things. And for me, then, the more that the compiler can do that, then the happier I am. So work with it, take note of what it is telling you. And if it is really obvious that you are trying to do something and you're just continuously hitting a brick wall and it's trying to send you in a different direction, then certainly take that as a hint that maybe what you're trying to do isn't the best way to do it. So don't try to get round the way that O1JS works generally. It's been designed that way for a good reason, and there's all sorts of security assumptions built into it, and security aspects designed into it. So don't work against those. Let it help you with those. Now the next point, or the next two points really kind of go together. The first point is perhaps more general in that one useful thing that we can do with our code is to have certain aspects of code being provable and then certain things not being provable, and that it would make sense that you wouldn't necessarily want to, you may want to do something but not have to have that as part of the provable code. And that's a valid thing to want to do, and it's a useful thing to be able to do. But it does also, you do have to be very careful about that. So you have to be very aware of what is involved in the proof, what code is going to be provable and what is not. And this brings me on to the third point there, which is about this aspect that I mentioned earlier, the idea of your code being under constraint, which is that if you have some checks within your code and you're using these to make sure that the right people are being involved to update some state, and that is being done in the right way, then make sure that those checks are part of the provable code. Because when that proof is being used, the assumption is sort of taken that, as long as we accept that proof, then that means that we can go ahead with the updates to the state. So if there are checks, and there typically will be checks that you will need to do, then those should be part of the proof. Otherwise, if they are not part of the proof, then an attacker could come in, they could change they could run your code differently and evade some of the checks, but still be able to produce a proof that the provable part of your code ran correctly, and therefore use that as an update, or to allow an update of the state. So this really, I think, is perhaps one of the most important things to be aware of, is that all of the checks, all of the security that you're going to build into your code has to be part of included in the proof, so that we know that those checks have been done. Okay. The next point is assumptions about the caller. Don't make assumptions about that. It could be anybody. If you need to have details about the caller, then you would need to be checking who is calling your code and checking for their details. Another point is around preconditions. This is perhaps more of an aspect of the logic of your code, but if it goes wrong, it can be problematic. It can cause your application to fail, in that there are going to be preconditions for the update to be applied, and I will go through this a little bit more in the examples that I've got, but you do need to be aware of what those preconditions are, and is your code relying on some preconditions? Is your code making some assumptions about certain state? And this sort of ties in with one of the more difficult aspects, I think, of writing zkApps, which is around synchronizing updates to state and making sure that we're not getting concurrency problems. So you do need to be aware of that, and aware that there are preconditions that will have to be met before the state will be updated. Okay. The next point is kind of general one, that it's just good practice to restrict the permissions as much as you can. And I suppose it's best to work from that direction. So, make your code as restrictive as you possibly can, and then relax those conditions as needed. Next point is about if you're making calls to other code, you need to be sure that is going to succeed, and that somebody could not do something malicious that would cause your code to fail. And we've got an example around this as well, where again, this is more of a kind of a denial of service type of attack than something that will be there to steal funds maybe, but it could be that someone would maliciously try to try to make your computation fail by setting permissions in a certain way in their code. Okay. The next point, make sure the access control. Really, this comes into the assumptions around permissions, etc. But yeah, so have an idea. Make sure you've got a very clear idea of the access control. Have you thought about the roles of the actors within your system? Can you map those to particular accounts? And once you've got that very clear and very well defined, is that then reflected in your code? And do you have checks within your code that enforces that? The next point is about testing. So this is, a more general point, goes back to Web 2 or earlier. Make sure you have sufficient tests. Make sure you have 100% coverage. Also, make sure you're not just testing the happy path and not just testing what you expect, how the code is expected to work, but you make sure that you're testing that malicious things cannot succeed. And in fact, the next point really should help you with this, in that one of the best things you can do is to give yourself an adversarial mindset. Get into the mindset of an attacker and go in and try and break your code. And this can be quite difficult if you've written the code, so it could be good to get somebody else involved here to help you out with this. But this really will pay dividends, and it's not something that people tend to do. People, particularly with testing, they tend to look to see if some functionality has worked, and then sort of move on from there and think that's the end of it. But it certainly isn't. You should go in and do your best to break the code and to think, imagine you're someone trying to go in and break this particular app or steal from this app. What could you do to do that? Is there any way that you can achieve that? Really try to do that, and you need to motivate yourself to do that, and that will certainly help your testing and certainly make your code more secure. The next point is to get your code audited. Now, for transparency, I should also say, we're an auditing firm. We are auditing on MINA as well. So obviously, it's great if you want to come and talk to us about that. But even if you don't, find someone to audit your code, or even if you don't go to an auditing company, which I do recommend you should, but even if you don't, then try to get somebody else to look at your code, get more eyes on your code. Because as a developer, it's very easy to overlook something or to have made some assumption. So it's much better if you can find somebody who's going to challenge those assumptions, and they may well find something that you've missed or overlooked. And even the best developers may well do that. So it's well worth getting other eyes on your code. And then from a practical point of view, have an idea of what are you going to do if your code is attacked? How can you recover from that? Obviously this is very specific to your application, but think about that in advance so that you're not having to think about it in a very stressful time if your code is being exploited. And then the final point here is very relevant now, in that we're at an incredibly early stage. I mean, in zk generally, we do have some examples of applications where vulnerabilities have been found, but MINA, obviously, we've only just had the update, and we've only just had the ability to run zkApps, and so we don't really have much experience of what could possibly go wrong and what is out there. And over time, of course, we will find this out. Now, obviously I would hope that we're not going to find anything, that there would be no attacks, but it's obviously not likely. So there will be vulnerabilities discovered. So keep up to date with the community, keep up to date with the documentation, so that what, if there are vulnerabilities, you can make sure that you don't have them in your code. All right, let me move on. So I've just got some simple examples here of potential things. Really, I think I've spoken about them, but there's some examples here, and this I think these are all taken from the documentation, but I wanted to just to talk through them. And the first one here is an example where we've set the permissions, but we've obviously not set them securely enough. So we've got we've set the send permission as none here, which means that then this account will then be allowed to send out tokens or send out MINA to someone who is doing this withdraw. And we're not actually going, we're not checking that in the permissions, which obviously is leaving our application wide open. So, and there's an example here then of how easily that could be exploited. So what we should do is then have something that is going to be required to check, to increase the permissions. So we could then set the send permissions to require a signature for this, so that somebody has to sign when that happens. But generally, better than that would be that we would want a proof. We would want to have some checks put in there, and then the proof to be supplied to show that those checks have been done and that those checks passed. Of course, that's just the first part. The second part then is that we need to say within our withdraw who can withdraw. We need to put in the logic, the business logic about that, of what someone is allowed to withdraw and who is allowed to withdraw, etc. So there's really two parts that we have to do to fix that then. So we have to get some permissions involved, and ideally we want the proof, so that when then we put the checks within our withdraw method, then we've got proof that those checks have been followed. Okay, so that's one example around permissions. Another example here under constrained authorization is similar to part of the last one, but very easy to do. You could imagine that we have some code. This is checking something about a user. Maybe we were checking that some aspect of their identity, something like that, or whether they're a member of a certain set, whatever it is. Now, you could have something, quite sophisticated and very, very clever doing that, but that, in a way, is all wasted if that check is not then part of the provable code, because that could then easily be bypassed. So, do these, have whatever kind of logic you want in there, have sophisticated logic, that's fine, but make sure that that check is then part of your provable code, and that the proof that we create does reflect that those checks have been done. So that's really the heart of under constrained code, and typically here for authorization. And then the last examples here, we've got a couple of ones where the code is too fragile to some extent. Now, this the first one is around permissioning. Now, I'm not trying to say that you should make your permissions too lax. Obviously, you don't want to do that, but you also do be aware of how permissions can be used, and particularly if you're involved with another contract, be aware that about their permissions as well, and what they could do to be, if they wanted to be malicious. And so there's further details if you look in the documentation. But the gist of this really is that you're calling a contract here, but they've set their permissions so that they've set something to be impossible, and this has really made the contract unusable. And they could put in something impossible within their code, also to make sure that would fail. So do be aware that if you're calling some contract, that you are making assumptions about that. You do have some trust of that. So minimize that trust as much as you can. And then the next point here is something to do that you need to think about when you're using the action and reducer pattern, because what this is all about is the fact that we are looking at multiple updates that are going to be happening to some state. And the example we have here is if you imagined you were doing an airdrop where you were going to be sending out tokens to multiple users, and if you're doing the reducer, if you're having the reducer to take these actions that are sending to the different recipients, then a malicious user could then set their permissions for this particular token, the receive permission, to be impossible, which would mean that their airdrop claim, would be failing because it's been set to impossible. They can't receive this token. But that also means, because this is being done effectively as a batch by using the reducer, then this means that the whole thing is going to fail. But there are ways we can get around that, ways where we can prevent users from changing their permissions, and there's details of that in the docs there as well. Okay, let me carry on. So just finish off then with some resources to help you. This was really just been an introduction to give you a starting point to thinking about security. The next sort of initiative that we're taking is we're creating an auditing course for MINA. So this is going to help you to understand security in more detail, and also help you improve your skills around auditing, so that you will be able to audit on MINA as well. So this is a course that we're building at the moment. It's a free course. We'll be releasing this as a number of videos on YouTube. So please check our channel, also check our socials as well. We're going to be giving out announcements about this, but yeah, we'll release those videos and go through security in more detail and auditing in more detail to help develop your skills on MINA. Other things that you may find useful, well, we've put together a repo, and this is a work in progress, that looks at examples of security and lists out some of the things you need to be aware of, and some of the useful documentation. As I say, we're building this, and so this is a work in progress, but we've got quite a lot there already. Other things you can do as well is if you join our Discord server, we will publicize our courses there as well, so you can get updates there. And then also we partnered with zkApps with an auditing initiative. If you want your application audited, you can do that through them, or you can contact us directly. But also they're a very good resource, because you can you get an idea from them of the other applications that are within the ecosystem, and things that have also been audited, so you can check the security of the applications out there as well. Okay, so there's some resources for you to be getting on with. This website is going to stay here, so I can update these notes as well. If you're interested in the auditing course, then you can get it here. This is going to be this comes back to this. Once we've started to release the videos, then we'll get that link working there, and you can follow that course. So that's everything from me. Just remains for me to thank all of you for listening in today. I hope that's been useful for you. Please keep building on MINA. It's a great platform. I think we can do some really exciting things with it. But please, when you're doing that, please make sure that your code is secure. The last thing we want is for your wonderful applications to have vulnerabilities and to be exploited. So thank you again, and yeah, have a great time developing on MINA. Thanks everyone. Bye bye.